Welcome to Chapter 9. This is Section 9.1, Number 1. We are going to be getting into some application problems involving right triangles. What you're going to be seeing over the next week is some things that you should have covered in geometry. So, to solve a right triangle means that you are going to find the missing lengths of sides and the measurements of its angles. Now, for this section, the textbook is very, very concise. Lengths of sides are always rounded to the nearest hundredth, so 2 decimal places, and the angles are measured to the nearest tenth of a degree. All right, so also make sure that your calculators, unlike the last section, make sure the degree or the mode is set in degrees. All right, so going on to the section, you want to label the right triangle as follows. All right, so when you have a right triangle, the way these are consistently set up is your capitals are for your angles, your lower cases are for your sides. The right angle is always called the capital C, and the hypotenuse then is a lowercase c. All right, what about the other two angles? Doesn't matter which one you call A and B, but wherever you put capital A, side A is the opposite of it. Wherever you put angle B, side B is the opposite. So side B has to be between angles A and C. All right, we have a little trig chart here on the right-hand side. Same thing as SOHCAHTOA. Please continue to use the SOHCAHTOA as well as this if you need it. You will not be given this chart when it comes time for your test or quiz. All right, so to be able to solve a right triangle, we must first know an acute angle and a side, or we need to know two sides. Now, generally when you're solving, that means you have to know 3 parts of a triangle, but for these problems, because we have a right triangle, we know we have a right angle, so that does consider to be our 3rd part. So we just need to find 2 additional parts of that triangle. So an acute angle and a side, or 2 sides, and then we can use one of our trig functions to find everything else. So 3 angles cannot be used because the triangles would be similar and the lengths of the sides could be any size. So we are not going to be using the 3 angles. So if you think back to geometry, when you talked about triangle congruencies, you had side, angle, side, 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 angle, angle, side. You had 5 different ways of proving triangles congruent. Angle, angle, angle was not one of those. That was for similar triangles when we used angle, angle. All right, so for our first problem, we are given that B is equal to 2. Notice the little lowercase b, so it's the length of a side. And A is a capital letter, and it is an angle. Does not matter where I put my A and my B, but my C, again, needs to be, oops, did that one wrong. My C needs to be the hypotenuse. All right, so my A is across from my A is my opposite, and my lowercase b is across from my B. So, given that information, I know that my length of my side is 2, and I know that angle A is 40 degrees. My goal on here is to find every single part of this triangle. So, I have an angle and I have a side. So, because I have an angle and a side, I have to use one of my trig functions in order to find it. You're going to do a couple different ones of these, and there's many different choices you can use. You could find angle B as 50 degrees and then use angle B as well. Generally, you want to stick to the ones we are given, though. So, if I want to find A, if I think about A, and I already have lowercase b, and I have my angle A, and if I go to my chart, if I have angle A, that means I want to look at this first side of my chart, and I'm given that I have side B. Well, side B, there are 2 different ratios that have side B in them. Side B is also my adjacent. So if you think about what has adjacent, it would be adjacent over hypotenuse for cosine and opposite over adjacent for tangent. So those are the 2 that I want to use to solve this problem. So I'm going to start with tangent. So tangent of A is going to be A over B, or opposite over adjacent. My angle was given to me as 40 degrees, so I can plug that into my formula. My side A I do not know. My side B is equal to 2. Now, when I go to solve this, it's just like cross multiply. So you can think about it as being over 1. You can also think about that I have to get rid of the 2 in the denominator, so I'm going to multiply both sides by 2. So in the calculator, you're going to type in 2 tangent of 40, and then hit enter. Make sure again that your mode of the calculator is in degrees. So solving this one, I should get A is equal to 1.68. When you go to solve this on your assignment, I highly suggest that you make a little table with those values in there. So I know that side A is 1.68. Side B was given to me as 2, and angle A was 40 degrees. Given that information, it's easy to be able to figure out C. C is also given to you as 90. And then, because it's a triangle, the angles of the triangle add up to equal 180. Or that you have the acute angles of the triangle are equal to 90 degrees. And so angle B has to be 50 degrees. All right, so we still have side C to find, which is the hypotenuse. Again, I want to continue to use the values that were given to me to start with. So I am going to use cosine of A equals B over C, where cosine of A equals adjacent over hypotenuse. Filling in my values that I know cosine, 40 degrees. My B value is 2, and my C value is what I'm trying to find. So notice this time my C is in the denominator. So this is one that you are going to have to do a little bit of thinking about. But if the variable's on the bottom, you're going to switch places. So if you have a proportion, so say I have 1 over 2 equals 3 over 6. Now I know that that is a true statement because 3 over 6 reduces to 1/2. If I switch the 2 and the 3, I will have 1/3 equals 2 over 6. That's still a true statement. So I can do it that way. Or if I switch the 1 and the 6, I could switch the 1 and the 6. Then I can have 6 over 2 equals 3 over 1. Also a true statement. So there's a little video that was made, getting tricky with it, and I will attach that video as well. And one of the things on it says, if the variable's on the down low, you switch, you know. And so this is going to be a divide. So we are going to take that C, it's going to go on the left-hand side, and we're actually going to divide by the cosine of 40. So that's what we're going to type into our calculators, 2 divided by the cosine of 40. And so C is equal to 2.61. So if you want to see a little bit more math involved with that, I'll show that at the end. All right, so those are our 6 answers for problem number 1. Same idea, we've kind of done this before, so we're redoing a lot of the things that we've done before. All right, next one, I know that A is equal to 3, B is equal to 2, those are sides, and I need to find side C, so I want to go ahead and do my labeling. Again, it does not matter where you put the capital A and B, as long as the lower cases are opposite from it. I know that side A is equal to 3, side B is equal to 2, and I want to find everything else. So I can put that information into my little chart, 3 and 2, and then also I know that angle C equals 90 degrees. All right, so if I'm given 2 sides, the easiest way to find the third side, Pythagorean theorem. So something we've done before. It doesn't matter which side you are missing, as long as you solve for it appropriately. So my C value is square root of 13, and I can add that to my picture. Now, when you go to do this into your chart, you do want to use the decimal value. Normally we leave it as radicals, but here they really want you to change it to a decimal, and because it's a side length, I do want to have it to 2 decimal places. So this is approximately 3.61. Now, I should never, ever, ever use that again unless I have no other choices. I always want to use the information that I'm given to start with, so that way I can find my values and have them be correct. All right, so define either A or B. Because I know sides A and B, I have to use tangent. I didn't know my hypotenuse to start with. And it doesn't matter whether I use tangent of A or tangent of B. I'm just going to use tangent of A. Remember that tangent is opposite over adjacent, so I want side A over side B. So my opposite is my 3, and my adjacent is my 2. So I'm using angle A in order to find the value, and the ratio is 3 over 2. All right, so what if I'm trying to find an angle? What do I do? So when I think about tangent, I know the value is 3 over 2. It's not on our trig library, so I can't go back to that. But what I want to think about is what is the angle? And this is where that key on your calculator that has the inverse key, this is where it's going to come into play. So that inverse key actually means what is the angle that has this ratio for the answer. So on my calculator, I will have to use that. So what does that look like for the problem? So what we are really doing is we are multiplying each side by the inverse tangent of 3 over 2. So on the left-hand side, those tangents are going to cancel. It just leaves me with A. And on the right-hand side, I have inverse tangent of 3 over 2. And because I want decimals, I'm okay to type that into the calculator, and it will give me my angle. All right, so this should be approximately 56.3 degrees, and I can add that to my answer sheet table. All right, so how do I find angle B? Now, I know I said don't use those decimals, but when you're doing the angles, that's the easiest way. So if I want to find angle B, I'm just going to take 90 minus angle A, or 90 minus the 56.3 degrees, and that's going to give me that angle B is equal to 33.7 degrees. Those two angles do need to add up to equal 180, or add up to equal 90, and then the three angles add up to equal 180. If you had found tangent of B, you would have found the 33.7 to start with, and then subtract from 180 in order to get the answer. All right, there's your assignment. Again, if you've got questions, please make sure you're emailing me to let me know. All right, good luck.